So hello everyone. I think we can start. It's 3:05 already. So welcome everyone to this ESA webinar. It is called Standardized the Orbit Interface Definition for Satcom-class Spacecraft, Phase 1. Before starting, we just want to give some instructions regarding the meeting, so please be aware that this webinar will be recorded. And if you have any questions, please post them in the chat. You can use either the chat or just write to the chat. You can see 3 dots, and there you have a Q&A panel. So you can go use both of them for the questions. As you can see, we have unmuted everyone because we have a large number of attendees, but we will have a question and answer session at the end, and we will try to answer some of your questions. And for sure, all of your questions will be collected and will be useful as inputs for us for this activity. So I'm going to present the speakers. The first in the screen is myself. I'm Estefania Padilla. I'm systems engineer for Clean Space for more than 3 years already, and I work in topics related to design for removal and more things. Then we have my colleague Marco Papa. He's also systems engineer for Clean Space. He joined the team recently, but he has a large background and experience in the sector. And we also have Callum Turner, which is a Clean Space young graduate trainee. In the next slide, we can see our moderators. We have Enrico Tormena, which is systems engineer for Clean Space, and Tommaso Turchetto, which is a Clean Space intern and is working with us currently. So just before starting with the context of the webinar, we can give you like a index of the content. So we will start with the background and the context. We will talk about the zero debris approach and the ESA space debris mitigation requirements. Then we will move to the activity overview itself. And we will conclude with some existing technologies and removal interfaces, some take-home messages, and a question and answer session, as I said before. So now I give the floor to my colleague Marco, who will start with the background and the context.
Thank you very much, Stefania. So good afternoon all. Thank you for joining this webinar. So let's start with some slides regarding the background and the context. So the zero debris approach and the ESA space debris mitigation requirement. So to start, the general, the usual slide, what regarding zero debris approach from the ESA Director General, highlighting the very important point regarding the dramatic increase of the space and the fact that there are not still technology to prevent the risk that follow. This is important also to highlight that the agency is leading this transition, this phase. So going more into detail, the next slide, please, Callum. Next slide, please. Yeah, we are reporting the zero debris scope and the different actors inside the agency that are taking part into this transition phase. First of all, on the left, you can see the effort related to the Independent Safety Office, TQI, that is leading the technical requirement definition for the ESA mission and the contribution. So the ESA space debris mitigation policy and standard. For sure, another very important part is related to the technical developments needed to obtain the very difficult, I would say, objective of this transition that imply the zero debris approach. For sure, there is an effort by the agency to support the industry transition and the compliance to the space debris mitigation standard. Another very important point will be is the zero debris technology booklet that shows the technical solution to reach the zero debris targets by 2030. And this is led by the Space Safety Program Office. Next slide, please, Callum. Going into more detail into the requirement, and first of all, to answer one of the most important questions addressed in this webinar, what is the D4R? With the D4R, we stand design for removal, and we means the set of the very specific design feature that allow the spacecraft to be ready to be removed by a servicer spacecraft. And you can see in this slide, for example, the Envisat case, that is one of the most important, I would say, spacecraft that has not been prepared for capture. And for sure, this imply a lot of challenge that are the challenge for the active debris removal. Design for removal implied a lot of dedicated modification to cover a certain kind of function in order to ease the removal by this external servicer. And another point that needs to be highlighted is the decrease of all the associated risk in performing this kind of activity, and for sure also the cost. The definitions, so the definition of a standard for the removal interface in terms of what needed function and technical requirement related is considered by the agency as an optimal approach for all the active debris removal technical challenges. Next slide, please, Callum. Here we are reporting some of the most important requirements related to the preparation for removal that are in the ESA requirement document, the Space Debris Mitigation Requirement Document that has been issued October last year. In this document, state all the requirements for the preparation of the removal of the spacecraft by an external servicer. The design for removal should facilitate the operation of removal, as I was saying before. This is very important to be highlighted, because potential issue related to the removal operation, including, for example, the close proximity and the rendezvous operation, are with this requirement preventively taken. Going more into details in this part, this requirement, and it's important to highlight the general point related to all these, covers different and several aspects. For sure, one of the most important is related to the applicability as an orbit environment of this requirement. And here, I will not go into the details of the requirement, but just try to highlight the main important point here. The important point here is that these requirements are applicable for LEO and GEO. In the image that you can find on the left, you can see all the rationale and all the application of the requirement. But here is important to define the boundary of the applicability of this requirement. The several aspects that are covered by the requirement are for sure the one related to the different functions I was mentioning before, that are for sure the mechanical interfaces to support the capture, the support to the relative navigation, that is another very important part of this activity, and all the maneuver required for capturing a satellite. Another point is the assessment on the long-term attitude evolution of the spacecraft, together with the attitude reconstruction from ground. These are for sure functions that needs to be taken into account when talking about removal operation. Another very important point is related to the dynamics of the spacecraft in the end of life condition. It is the fifth point that you can see in this slide. That is called limiting and damping the angular rate of the spacecraft. For sure, another very important point is more related to, you can say, the environment, more than to function related to removal, is the difference between the cooperative and uncooperative scenario. Mostly for the consequences that this has, for example, on the spacecraft design, and more in particular for the OCS subsystem. So here we reported the requirement text just to go into detail and trying to explain the end to highlight the main point for all these functions we listed. So, for example, for the mechanical interface, the support to relative navigation and the assessment of the long-term evolution, these functions are addressed by specific requirement in the document. Here, the important part, mostly for the mechanical interface, is to highlight that the requirement is not prescribing a specific design, but is highlighting some characteristics, some feature that the mechanical interface for removal should have. For example, Note 1, you can see, as it states as a good practice, that the mechanical capture interface allows for capture before contact. This is for sure something that is very important when designing an interface for a mechanical interface for capture. For sure, another important point is the one related to the assessment of the long-term attitude. And also this part is specifically addressed by the space debris mitigation requirement, as it is fundamental, it is critical to have an assessment regarding the evolution of the attitude in order to easy all the part related, for example, to the rendezvous and the close proximity operation. So going further, we can see here the requirement related to the attitude reconstruction from ground and the limiting and damping for the angular rates. It's important here to highlight, not going into the details of the requirement, but just to highlight, for example, for this function, limiting and damping angular rates, the document is reporting actually the magnitude, for example, for the angular rate vector. This is quite important because it's giving an indication what should be expected, both from an active, you can say, perspective, so a service perspective, but also from a satellite integrator's perspective. This is quite important because it's also reporting different measures to limit and damp the angular rate. And these are reported directly in the requirement. For example, one point that needs to be highlighted is all the part related to the passivation of the propulsion subsystem in order to not increase the spacecraft angular rate. So we start to understand there are specific constraints and specific technological challenges to be tackled when talking about a removal operation. another very important point that is related, for example, to the OCS is all the part related to the orientation of the appendages when, and this is the requirement is highlighting a specific OCS mode, when the spacecraft is in safe mode, in end-of-life condition, in order to minimize the dynamic effect that could result from the torque coming from the solar radiation pressure. This is quite important because starting from this requirement, we start to have constraint to the removal that needs to be taken into account, as they are very general and applicable to this operation. For what regard the last point, that is the cooperative and uncooperative scenario, the document is directly considering this case, and what would be important to highlight is not only the difference between the cooperative and uncooperative scenario, but what are the implications in the cooperative scenario. Here, this requirement, for example, is highlighting the necessity for in the removal to consider specific design for the system modes. This as implication and consideration needs to be taken into consideration when defining the OCS subsystem. Here we reported some aspects that are specific for removal, that are important when considering a standardization effort. First of all, it's worth to say, it's worth to highlight that the objective of the standardization is to produce technical requirement specification for a standard interface that needs to be done in accordance with the selection of the feature to be implemented. It's quite important to highlight the point of the selection of the feature that needs to be implemented in order to define a technical requirement specification for a standard interface. Here you can see basically the various functions, the various space-to-space interface, with a difference for what regard the mechanical interface. Differences between the passive side and the active side, because these have different aspects that needs to be considered. First of all, staying just on the mechanical interface, for the passive one of the important aspects that needs to be taken into account are all the constraints in terms of loads that are typical and specific for the removal scenario. This will lead also to keep out zone constraint. It's an aspect that is in common also with the GNC interface. But what is important to highlight is also the compatibility with docking and berthing interfaces. As you say, with the general iOS interfaces. For sure, this is a very important aspect that needs to be taken into account when talking about removal, because removal can be considered as part of the more general iOS world. It is important to understand which are the different aspects and which are the possible compatibility and interoperability with different interfaces. From the active side, is important, at the end, as an aspect to be highlighted, the possibility to think to a common passive mechanical interface for the removal. Talking about just a bit regarding the GNC interface, because for sure one of the most important aspects that needs to be considered are the part related to the rendezvous dates attached to the client. Another point that is worth to mention is all the constraints related to LCS. As I was mentioning before, just going through briefly the various requirements in the space debris mitigation requirement document, is clear that the removal operation put a lot of constraint for the design of the OCS constraint, the OCS, and specific to the modes that need to be considered in this kind of operation. And here is important also to link the different scenario between the cooperative and the uncooperative scenario. Remaining on the agency interface, the last point would be all the constraint on the approach direction by the client. These are all part related also to the accommodation of the various hardware that needs to be accounted for in the removal. First of all, the position of this mechanical interface. Another point that is in common also with the active mechanical interface, it's the same value, is the keep out zone constraint. Another point is all the part related to the thermal environment and the thermal constraint. The last point for what regard the interfaces are related to the other two functions that needs to be highlighted. That is, first of all, the detumbling. And the other one is the attitude reconstruction from ground. Now we leave the floor to Stefania for the part related to the activity overview.
Thank you, Marco. Thanks for this background that you explained. So let's go to the activity overview. So the name of the activity we know is pretty long. Sorry for that. I just want to repeat it because it's important to have it in mind. So standardize the orbit interface definition for Satcom-class spacecraft. So here we try to explain the objective of the whole activity, and as the name says, it is the definition of the interface. So we are not trying to develop or generate a hardware, but we are trying to generate a standard for an interface for in-orbit satellite-to-satellite latching for the orbiting. And this last part is also important. We are targeting only the service of the orbiting. It is true that the outcome of this activity could be an input or could be something to explore and to enlarge and to try to generalize for other services. But right now we are only targeting the orbiting. And as I said, it is really important that we are not developing a hardware, but a standard. Then different interfaces could be designed and manufactured in line with this standard, but they could be even different. Then the second point, the interface should facilitate the non-cooperative rendezvous and capture of telecom-class platforms, but of course other platform classes, other spacecraft classes could be benefited by this standard too, because the same standard could apply to different spacecraft classes. And the last point is really important. So our intention is to have industry and all interested parties engaged through the process, and that we take into account the inputs from everyone. So if we go to the next slide, here we just try to explain a bit what we understand by a standard. And it is true that it is still not clear maybe the level of granularity that we will achieve, because this is something that will be defined through the activity and also with your help. But just to give you an idea, we believe that a standard deorbit interface should cover 4 main functions. So here we have the capture, the relative navigation for rendezvous, attitude reconstruction from ground, and the tumbling. And then within each of the functions, we can have different sub-functions, let's call it like this, in the standard. So for example, capture before contact, or sustain the transversal loads during the capture and also during the deorbiting, which might be higher. Then including navigation aids for rendezvous and close proximity operation. This is something that is pretty clear. But then including features for attitude determination from ground and also enable the tumbling of the target is something that sometimes is forgotten. And it's really important because when we have a target that is non-cooperative and we don't have any control over it, we need to know what is the attitude, what is the spin rate of the target before sending a servicer there to catch it. And maybe the servicer is not even capable of capturing this target. So here is where the tumbling part takes importance, because if we have something to decrease the spin rate of the target, we could enable the service of the deorbiting. So this is more or less the initial idea that we have about the standard, but as I said before, the standard itself will be the outcome of the whole activity. So this is something that we will define in the coming months. If we go to the next slide, here we can see the general overview of the activity. So we have divided it into 4 phases. And today we are just starting phase 1. This phase 1 is called Discovery and Engagement, and it has a 3 months duration. So it will finish around the end of July. What we are trying to do in this phase 1 is to collect existing interfaces information and also to collect inputs from users, service providers, etc. This will be done, I will explain the next slide. So we will do with this webinar, also we will have a final workshop, we will have surveys and bilateral videos. So I will explain the next slide. And the outcome of this phase 1 will be the user's needs identification, so your needs, and also the definition of different static cases that will serve as an input for phase 2. So this phase 2 is still not defined, but we have a draft idea. We have called it a standard draft definition, and the goal is to draft an interface standard. Probably it will be done in a CDF, and the duration is still to be defined. And this will be the input for phase 3 and 4. Phase 3 is design, prototype, and standard consolidation. And phase 4 is just the delivery of the outcomes. And this, we planning to do it with 2 parallel contracts with industry. So then these 2 parallel contracts will have the same input, this draft interface standard, and the output will be a verified standard. So this is the most important thing. Also, we are thinking about including that they need to develop different prototypes in line with the standard. So then they don't see each other, but at the end we can try to compare the different hardware that is coming out in line with the same standard. And of course, this will be inputs for hardware development in the future. So this is the general overview of the activity, but I want to highlight that now we are just talking about phase 1, and we are just starting phase 1. So the outcome of this phase is not the standard. It is just to identify the user's needs and to define different static cases for the next phases. So how we plan to do this? We have started with the stakeholders identification. this, let's say, is already done. But of course, if you think there is that some stakeholders are missing, or you have information that could be useful for us, you can always send it to us by email, cleanspace@esa.in. After this, we are having this initial webinar, which is today, 4th of June. And then we have defined a survey that will be open on Friday, so this Friday, and will close on Sunday, 23rd of June. And here it is really important for us that you answer the survey. So we will share the details on how to access the survey on Friday, hopefully to all the registered participants. And we will be expecting your answers for sure. Then we will have different bilateral meetings with industry, depending on the answers received from the survey. Maybe we need clarification on some points. So this will be something defining case by case. Maybe for some surveys there is no need for a bilateral, but for other years. So this is something that we will define depending on the content and the results and the answers, of the survey. And with all of this information, all of these outputs, we will consolidate everything, and the results will be presented in a final workshop, which is currently planned, still to be confirmed, for Thursday, 25th of July. And you will receive more details in the future. Just as a note, we just want to let you know that it is not only us who are involved in this activity. We also have an internal group of experts in different fields at ESA, and they are giving us support on the definition of the slides for today, the survey, and for sure for the final workshop. So just wanted to mention this. So now let's focus on the survey content. So I give the floor to my colleague, Callum. Thank you.
Thank you, Stephanie. So I'll talk through the mechanics of the survey and some of the questions you can expect in it. And towards the end of this part of the presentation, you'll also learn a little bit more. We'll reiterate the dates so you know everything you need to fill out the survey. As mentioned, this is quite high level at this point. We're in the discovery and engagement phase of this activity. So all we really want to do with this survey is to identify user needs and define study cases. We've followed the logic of the functions that we believe are necessary for a removal interface. So the first 4 sections of the survey are going to cover capture, relative navigation for rendezvous, attitude reconstruction from ground, and detumbling. And we'll also be trying to gather your thoughts in a fifth section on how we should approach the standardization. Any inputs you have there will be very much appreciated. So let's go through section by section on what you can expect, the kind of questions, and an idea of the kind of level the survey's at. So in the section on capture, as I mentioned, we'll be looking for user needs and identifying study cases. We'll also be looking for things like key drivers for passive mechanical interfaces. Questions on that might be, as you see on the left here, something like, what do you find most important? So as the driver, the mass, the cost, the envelope, load transmissibility, the material properties, or accommodating this hardware on a satellite. So that's the kind of level of the question you can expect. We'll also be trying to get to know the respondents to the survey, to engage with the community at large. So we'll be asking if you or your organization have any experience in developing technologies for interfaces, for active grasping of interfaces, and to describe as far as possible. This is maybe a good moment to mention, please don't share anything proprietary. This is quite high level, not at all granular. We can have bilateral meetings and go into a little bit more depth later on in the activity. So moving on from capture into the section on relative navigation for rendezvous. Similarly, we'll be looking for user needs, design drivers, and a little bit of an overview of what the respondents to the survey have in terms of experience. So we'll be looking for any specific technologies. We'll also be looking for slightly more specific information here, like if you have embarked navigation age, what kind of sensors do you assume to be on a chaser spacecraft? So if you're looking at this your satellite equipped with navigation aids, what do you expect to be looking at it with? Things like that. And in case we've missed anything, we've got these 4 features that we mentioned. We'll also be asking for any other necessary features, just specifically on CPO navigation aids. So moving on to attitude reconstruction from ground. Again, a similar level of user needs, identifying what the drivers are here. And maybe a more specific question you can expect here is, what features do you consider necessary for embarked hardware? For embarked hardware in this use case, you'd expect something like laser retroreflectors. What would you need from this hardware to be able to reconstruct an attitude of the satellite from ground? As we mentioned earlier in the presentation, this is useful if, for example, you lose control of a target and you need to go and remove it, and you need to reconstruct its attitude before determining if it's worth sending a servicing vehicle. So, moving on to detumbling. The 4th section of the survey, similar to the other ones, we'll be looking for any kind of experience, you to share any inputs into the standardization activity. The most technical level of question you could expect here is something like the maximum angular rate of a target space object that a system you developed could support in terms of detumbling. I believe that's all on the survey for now, except for the final point here, which is to talk about the standardization approach. So these slides are very slightly out of date because as of today, we're still finalizing the questions. So here we'll be asking a few more detailed questions on how we should approach this standardization and what you see is a useful approach for ESA to take here. So, going through the mechanics. Everyone who's attended this webinar, or indeed everyone who's registered to attend this webinar, will receive a link with the survey. The tool we've chosen to use is Microsoft Forms, so you can get a link, fill it out. Please do share it with other people. We'd appreciate it if you pass it on to colleagues, any other interested stakeholders. We want as wide an engagement as possible at this stage of the activity. To reiterate the dates, we'll send this out on Friday morning, and it will close on Sunday the 23rd, so you'll have about 2 weeks' time to fill out this survey. Depending on how you answer it, different questions will be available for you. So if you have no experience in one of the particular functions I mentioned, then you won't be bombarded with questions you need to fill out on something you don't have experience in. And we expect you to take about 15 to 20 minutes of your time, so not too long at all. And to reiterate, it's quite high level at this stage, so we're not asking for granular technical detail, though I suppose feel free to provide it if you wish. As mentioned, the next stage of this activity is to set up some bilateral meetings. So if you would like to already know that you'd like to set up a bilateral meeting, please get in touch at cleanspace@esa.int. So now that we've covered the mechanics of the survey, move on and take a very, very brief look at some of the existing deorbiting interfaces. So we can start by talking a little about some of the common technical features of these interfaces before we go into specific examples. So for space interfaces in general, these usually end up being symmetrical, trilateral or quadrilateral symmetry. You often find they integrate some kind of fiducial marker or a retroreflector for relative navigation. They're capable of self-alignment through pins or petal. That means there's a little bit of give where these interfaces connect, they can self-align. And also some of them are self-compatible. You also occasionally see this referred to as androgynous interfaces. So an interface of type A can connect to an interface of type A rather than to type A to type B. There are a few challenges in space interfaces I'll briefly touch on here. There's many options, many have been developed. However, there are relatively few open standards. Something we're hoping to address with this activity. Specific to this activity, the features required for in-orbit servicing interfaces in general differ from the needs for deorbiting interfaces. So there's a slightly different use case, which we'll explore more in a couple of slides. And a final challenge that we've come across is that many interfaces for deorbiting don't support some of the functions that we identified, specifically detumbling or attitude reconstruction from ground, both of which we believe are important for designing satellites for removal. So, take a very brief tour of some existing deorbit interfaces. A massive caveat here that this is not an exhaustive list, this is just a selection and other interfaces are available. So, on the first side, on the left side here of the screen, you can see ESA's design for removal hardware. So this is a combination of a passive mechanical interface, markers to enable relative navigation, markers for attitude reconstruction from ground, and magnet hawkers which can be shorted to detumble at the end of its life. So these have been developed and implemented in 4 out of 6 of the Copernicus expansion missions. There are also options available in the commercial market. So 2 examples here are the Astroscale docking plate and dog tag by Voyager Space, I believe. So these are both lightweight interfaces with a variety of capture mechanisms, and you can see that they both integrate these fiducial markers that I talked about just a slide ago. So moving on from there, there are not only existing technologies, but existing activities on standardizing deorbiting interfaces, and indeed in-orbit servicing interfaces in general. So the activity we're describing today complements parallel activities both within ESA and within the European space sector more broadly. So in ESA, 2 activities to mention in-space proof of concepts 1 and 2. So as you can see from the diagram here, in-space proof of concept 1 focuses on grappling, dockling, and interconnections, whereas in-space proof of concept 2 focuses more on refueling. There's also space USB, which focuses on interconnect, so interconnecting systems in orbit. And to reiterate, this activity focuses on deorbiting and deorbiting alone. Our aim here is to build as large as possible a group of stakeholders and really focus in just on this use case. As a final note here, one of the outcomes of this activity is expected to be the inputs to ongoing standardization activities in the wider space industry. For example, CONFAS is somewhere where we hope to provide input based on this activity. So that is all from me, and I'll pass back to Marco to conclude the webinar.
Thank you very much, Callum, for all this part. Just few messages as a conclusion for this webinar. First of all, the main message here is that for this kind of activity, your input are needed. Basically, in order to have as much as possible identification of the user needs, we need you to complete the survey that Callum has explained before. So here we report the information regarding closure of the survey that will be on the 23rd of this month. And the next step would be the presentation of these final outputs in a workshop that needs to be organized at the end of July. So we are highlighting here a date that still needs to be confirmed, but we meet at the end of the next month. So this will conclude then, as Stefania was explaining before, and the review of the activity, the first part of this activity. Now we have a section related to the question and answer. I can see that there are some points that have been highlighted by you. Thank you very much for this question. I think we cannot go through all the question that's been raised, but I think that it would be worth to start to answer some of them. First of all, the first one is much more related to the organization of the outcome of this webinar. So the first question is asking for sharing of the slide, as Enrico is reporting in the chat. The answer is yes. The presentation will be shared with all of you.
Okay, I think I will take some question now. We try to collect some of the questions from the chat and the Q&A on webinars. Some of the definition we already tried to reply, but the most, let's say, important question on the topic, we would prefer to raise them directly to the presenters. So I'll start with the first one. What does removal in geo means? And does it include moving the space object to graveyard orbit? Who's gonna take the question? Marco or Stefania?
I can go with this one.
Super fair.
It's not a problem. The answer to this question, the simple answer is yes. In this particular case of the geostationary orbit, is meant the moving the space object to a graveyard orbit. So this is the meaning of removal in this case.
If I could add an extra point on that, there's also an edge case in which you're not removing geosatellites from GEO, but if they're stranded on the way to GEO. So there was a historical case, I believe, of an Intelsat that didn't manage to complete its orbit raise. And had it been designed for removal, it would have been a lot easier to remove it. And I believe it was successfully raised, but only with astronauts on the shuttle.
Very good, thank you. Following on, there was another question that was referring to, let's say, in case of design for removal will be used in case of failure of the nominal controlled or controlled re-entry, and as such, all devices shall be passive, as it cannot be guaranteed that active devices could be operated. Is that right?
So I can take the question. So yeah, the short answer is yes. So this is exactly what we call non-cooperative targets. So yes, the devices shall be passive, as we are assuming that we will not have control over the target in this non-cooperative scenario. We also cover the cooperative one, but it is really weird to happen because it means that you have some control over the target, but it cannot perform the deorbiting. So I don't know if Marco or Callum, you want to add something on this point?
Okay, no. If it's good, we can go on with the next question because we have just a few minutes left. There is already a standard passive mechanical interface being implemented for the Copernicus satellites, which is MICE. It has been validated with an active mechanical interface CAT, and there is even an IOD mission planned. The question is, why is this not implemented to SATCOM as well?
So it is a really good question. I can start, and then if you want, you can complement. So in this activity, let's say that the main goal is to involve everyone in defining this standard. Of course, a lot of work has been done in the past regarding design for removal, and it is true that we, together with industry, ESA has developed MICE and also the hardware, and we are also developing CAT, etc. But the main point is that we are not in a position of imposing any hardware. So this is why we are moving more in the way of defining a standard. And then our expectation in the future is obviously that MICE will be in line with this standard. But this is yeah, let's say that this is the difference. The thing that we are saying, we were saying at the beginning, that the goal is to define a standard, a common standard for everyone, and then different hardware could be developed in line with that standard.
Okay. Yes, for sure. Not just to add a few points on this, because it's I think it's a very good question, and basically another point that needs to be added, maybe to clarify on this, in addition to what Stefania was saying, is that basically this activity is for the further investigation of the need and the requirement for the Satcom-class spacecraft. Because for sure this is a point that needs to be highlighted in this frame. So it's true that there are a lot of activities, a lot of hardware already developed for removal, and but this is not actually the objective of this activity. But for sure, all the experience that has been acquired with the developing of this hardware could be useful and actually are critical for this kind of activity related to the standardization. So these are, for me, the 2 points that needs to be highlighted here with respect to this question.
Yeah. Also, one point that I forgot before is that in the end, MICE was developed for large satellites in LEO, and could be the output of this activity that we need different static cases, for example, for other kind of spacecraft, so a smaller spacecraft or a spacecraft in GEO. So maybe we came out with the conclusion that we need 3 different standards instead of only one, or we don't know, because this is something that will be developed in the activity. But MICE was developed and also optimized for big spacecraft in LEO. So we need to see if it is also the best solution for other study cases, let's say.
Okay, so here I see another question, and it asks, does this standard cover SATCOM satellites in geostationary, MEO, and LEO? I don't know who wants to take this question.
I can take it. For sure, this is one of the goals of this first phase. As we were mentioning before, the 2 main points for this phase 1 would be the identification of the user needs, and also the selection of the different study cases that should be covered by this standard. So for sure, the part related to the orbital environment that needs to be considered is seen as part of the selection of the different study cases.
Anyone wants to add anything?
There was one point I wanted to add. I saw there's a question on Confus, is that right? Or have I missed that?
Yep.
Yeah.
Perfect. So yes, contact has been established with Confus, to clarify that point. They're one of the bilaterals we hope to hold in the next stages of this activity.
Okay. I think that now there's the time only for the last questions, if I'm not mistaken. So the question is, from a standardization point of view, how mature is this to date? And the person continued to say that successful standardization needs maturity and experience. He gets the impression that this is currently more at a conceptual stage, more ongoing development, less subtle experience.
Yeah, so I can maybe start. Yeah, for sure, we are, as we explained during the webinar, we are just starting this activity. So the standard is not started, let's say. Of course, there is a lot of work that has already been done in the past in this field that will help a lot, not only from ESA, but from industry, a lot of work already done that they will speed and help a lot on on this activity. But the quick answer is that this standard is not mature still, because we are just starting this effort.
Very good. So thanks a lot for the answer, Marco, Stefania, and Callum. I think it was really clarifying the main topics on the subject. I've seen also that in the chat and the Q&A we received actually other questions while we're actually replying to the Q&A. We saved them, and we will try to get back as soon as possible to you, so that everyone is gonna receive their answer properly. And thanks everyone for participating. Thanks Marco, Stefania, and Callum for presenting. I'll leave you the last words for closing the webinar.
Yeah, thank you very much, Enrico. Thank you very much, Tommaso. And here is just to recall the main event for this year related to clean space. And then, so all the next very important event will be the 0 degree week at the end of this month in ESOC. You can find an indication, the link for the video. And another very important event will be held here in ESTEC beginning October, talking about the Clean Space Days. You can find all the useful information in the link in this slide. And you can find the contact page here on the right in this slide. I would like to thank you, all my colleagues, for the very good presentation and all the participants. I can see that there are a lot of questions. Unfortunately, we have not time to go through during this webinar. I think that they are raising a very important point related to all the different aspects for the removal and all the activity in general related to the iOS and the relationship between these various. So this is for sure something important, and as Enrico said before, we will come to you as soon as possible with the answer to all the questions. Thank you again for participating to this webinar.
Thank you very much.
Goodbye, everyone. Thanks for participating.
Thank you. Bye bye.
Thank you.
Thank you.
Bye bye.